Alright, so now we're going to go over how to remove nodes from a linked list. So we're going to start with the implementation that's not within the class. So here, building, printing, and then this is what remove is going to look like. Similar to insert, we're going to remove a particular index. So if we number our nodes, it just allows us to remove a particular node. You could write this all sorts of different ways, but this was interesting enough that it gives you a nice example of how to do all the linkage. So let's first call remove on 1. The code is really similar to insert, and so you do a similar thing where you need to walk through the list and find the index, and then all the code in here is once you actually find that index. So if you're not on the first node, if you want to remove 1, all you're going to do is take the previous node and link it to the next node. So this is node, this is previous, and this is nodes next. So all you're going to do is run this line right here, which is going to take previous is next and point it to nodes next. And so that basically updates the wiring. You want to do that first, right? And then once you've done that, then you're going to go ahead and delete the node. If you don't do it first, then you're going to lose this, and so you won't know what to link the prev next to. And so that's the whole idea. Once you do that, then you break out and you're done. The edge case for this one is if it's the front of the list that you're going to be removing. So let me remove all of this. So it would be this call here. So if you're going to do the front of the list, then in this case, you're going to find the first index. So prev is going to be pointing to a null because it never gets set because there's nothing before it. Node is going to point here. So node next is going to point here. Which is totally unnecessary to draw, but I'm going to anyway. So node next. So now if you are at the first node, what you're going to want to do is update the list to point to node next. Which is what this line does here. And then you're just going to delete the node. So those are the two different cases of how it works inside of main. Now if you're building a class, the difference is that you don't need to pass in a parameter to remove to the linked list because you can just use the front, which is stored, and then basically the rest of the code is exactly the same. It's just instead of updating list, you're going to update front, and then you're also going to want to make sure to update the size when you delete. So every time you call new, increment the size. Every time you call delete, you're going to decrement the size. And that's how remove works. Remove is like a little bit easier than insert in some ways. I don't know. That's not true. They're kind of the same. So inside of the Memer example, you can run this. So let's just do the class. I think you get the idea. But if you want to play around with this at all this code is linked in the next video, and so you can run all sorts of different other cases with this as well. So this is going to remove the 0th and the second index. So this is going to ask me for, oh, I should have done a 0 start. Okay, so 0, 1, 2, 3, 4, 5 is the beginning, and then it's going to remove the 0th first, which is the first, so now we only have 2, 3, 4, 5, and then it's gonna remove the second, which is 4, so then that prints next. It's also a good idea to run valgrind once you start removing stuff to make sure that you've removed it properly and that you're not trying to remove it again or something like that, which with linked list is generally not a problem if you've relinked everything. So if you're printing it, that link would show up being broken as well. But this is how you can remove at a particular index in a linked list.